This is mercury! The symbol for Hg, mercury, comes from the Latin word hydrargyrum, meaning liquid silver. Mercury is the 80th element, weighing it at a massive 259 grams per mole. It has a melting point of a whopping negative 39 degrees Celsius and boils at a mere 360 degrees Celsius. Mercury has been found in the transcripts of the Chinese and Hindu, however, was found in Egyptian tombs dating as far back as 1500 BC. So how does this liquid metal come to be? Well, it starts out as cinnabar, or mercury sulfide, which is basically just a grayish-black rock found primarily in Spain and Italy. So where's the liquid silver, you ask? Throw it on a hot plate to see. The mercury will boil out of the cinnabar. If you wish to actually capture the mercury, you must capture the mercury vapor and then run it through a condenser. Then you'll see small round drops of liquid silver falling from your condenser. How much will this freaking sweet poisonous liquid metal cost a fellow these days? Well, anywhere from $650 to $700. The market has a standard unit for mercury sales, which is called a flask, which weighs in at a nice 71 pounds. Now, it is important to note that mercury prices are about as stable as the stock market and have been changing drastically in the past year or so. So $650 to $700 was the best estimate I could find for mercury prices these days. Now let's talk about some uses of mercury. Barometers are used to measure atmospheric pressure in millimeters of mercury. Thermometers are used to measure temperature, because mercury is very sensitive to the temperature changes. Silent switches, also referred to as tilt switches, are used in automobiles, bombs, and vending machines. Mercury is also used to make fillings in your teeth by forming an amalgam with silver, copper, tin, and zinc. Also, mercury is used in mining of precious metals like gold. Some other mercury compounds include mercuric chloride and mercurous chloride. Mercuric chloride is a poisonous salt that was once used to disinfect wounds, while mercurous chloride is used as an antiseptic to kill bacteria. And then there's the good old mercury sulfide, which is used in red paint. So don't go around eating too much red paint. The density of mercury is 13.5336 grams per centimeter cubed. It has 7 known stable isotopes and an ionization energy of 10.43 eV. It has 2 oxidation states, one of +2 and one of +1. Now enough of the book work, let's play with some mercury. Alright, so we're going to talk about the weights here, and as reference I'm going to use some water here. So we got a little bit of water in the vial and mercury about the same height, and we're going to weigh them. So let's throw the water on there, and we get 10 grams. Now keep in mind that the vial weighs around 8 grams, so there's probably about 2 grams of water in there. Throw this guy on here, and we're sitting right around 46 grams of mercury. Here we have a dirty dime, and it's from actually 1966. Nice year. We're going to use it to clean. We're going to clean it with some mercury here. So what's going to happen? Oh, I'm going to pour this in here first, and then I'm going to put this dime in here. We're going to swish it around. What we're making here is a silver amalgam on the surface of the dime. So we'll swish it around. Alright, so here's the mercury beating heart. As you can see, we have a mercury blob in the center, and it is covered with a thin layer of 6 molar sulfuric acid. Okay, we placed 1 granule of potassium dichromate on the mercury blob. The potassium dichromate oxidizes the mercury to produce mercury 1 ions, which combine with sulfate ions to produce a thin layer of mercury 1 sulfate. This thin layer reduces the surface tension of the mercury, which causes the blob to flatten out. When the blob touches the nail, it allows the electrons to flow from the iron nail to the mercury. This reduces the mercury 1 ions back to mercury metal, thus regaining its original surface tension and allowing the blob to contract. When the blob loses contact with the nail, it then produces that thin layer of mercury 1 sulfate ions again. The blob flattens out, and the process repeats. Alright, so now we're going to freeze it, and so, well, I've got some dry ice here. Let's go ahead and I'm just going to bury this in here. And all I did to this dry ice was put it in some Kroger bags and banged it on the ground, so it made it smaller. So it'll really... Now, you're not supposed to touch dry ice like this, so don't do it at home. Alright, and let's pull it out. Look at that, gentlemen and ladies and gentlemen, we have frozen mercury. Here we go. Yeah, let's get a close up on that. Now I'm going to start slowly melting it back here. And here we go, we're starting to melt it there. And you can tell it should. Alright, so now we have a mercury vortex. Alright, so what's going to happen is we have a positive electrode, and that big ring around the bottom is our negative electrode, and then we got that pool of mercury in the bottom. So the mercury is acting as a conductor here in between the positive and the negative, or the positive and the negative. And so what's going to happen is the current is going to start flowing through the mercury. And as those electrons are moving, I've got a handy dandy magnet on the bottom here. And so moving current in a magnetic field, as you will learn in any basic physics class, will start to make it spin. Alright, so let's actually start doing that here. So right now there's no voltage. I'm going to start turning that on, and you can see it just start swirling. There we go, and we're making nice little vortex.